All right. We are graphing absolute value equations and then inequalities as well. So we have a couple examples. One, we're going to do two of these equations and then two inequalities, and then should be good to go. Okay? So before we even start graphing, okay, we need to understand some previous concepts, some previous stuff. So first off, our general form of an absolute value equation is y is equal to a times the absolute value of bx plus c plus d. Okay, and so all of those letters are important things. The y and the x, again, are going to be there no matter what, but the other numbers are going to change. And every number has a specific spot that they're always at. They also have a reason that they're there. Okay, so they cause the graph to move, shift, up, down, left, right, skinny, narrow, or a little fatter, flatter, whatever else there is. So with an absolute value equation, we know that it's going to look like a V. Okay, because absolute value has symmetric properties to it. Because if I put the number 2 in, I get 2 out. Like absolute value of 2 is 2, because the absolute value of 2 is 2. But the absolute value of negative 2 is also 2. So because of the symmetric properties of absolute value, that is why it looks like a V. Okay? So now let's actually get to determining how we graph. So one way is you can plug in x, y, t-chart. Okay? And x could be 1, and you plug it in, and what do you get for y, and so on and so forth. But there's a little bit different way to do that. You don't have to do it all the time. There's easier ways to do it. So here are some easier ways. Okay? This is going to help you down the road for graphing quadratics and factoring and solving by factoring and that sort of stuff. So vertex is the point at which the two kind of rays come together and kind of meet. So our vertex is going to be negative c over b, comma d. Negative c technically just means the opposite of c. Okay, whenever we see a negative in front of a variable, all that means is just the opposite of whatever that number is. Then there's a couple different things that the a does. The a, if it's positive, that means the graph opens up. Okay, so it looks like an actual V. If the a is less than 0, then it opens down, and then it looks like an upside down V. So this is right side up V. This one is an upside down V. Okay, well, good. Now I have those two things. Well, again, there's something else that's important as well. What we need to do is find slope. The slope is not just from the B, it's not just from the A, it's the combination of both of them. So whatever A times B is, that's how much you go up or down, okay, depending upon whatever A is, right? And then we move over 1 or 2 or whatever the denominator is, rise over run. So let's do this particular problem here. I'm going to write it like the general form so I can see kind of the similarities. So this is y is equal to 1 absolute value of 1x plus 4 minus 2. So this is A, that's B, that's C, and that is D. Okay, vertex. Negative c, the opposite of c, negative 4. Divide by b, which is 1, comma, negative 2, which is our d. So our vertex is negative 4, negative 2. So let's graph it. Negative 4, negative 2, right there. Remember, I go left or right first, and then up or down, depending upon what your x's and y's are. Second thing, is A greater or less than 0? Well, A is 1, which is greater than 0. So I know my graph is going to open up. Now I need to find slope. A is 1, B is 1, so I multiply them and I get 1. So from my vertex, I'm going to go up 1 and right 1, because that was my slope. But because of the symmetric properties of absolute value, I actually have to reflect that over what we call, say, the axis of symmetry. So I'm going to reflect it over, which is right there, up 1, left 1. So now I have my graph. And And there we go. That is the graph of number 1. Okay, so now this particular problem's got a whole bunch of other numbers. It looks like there's numbers in every one of the spots. So we have an A, we have a B, have a C, and we have a D. We're going to find the vertex first. So vertex was the opposite of C, which is positive now because C was negative, divide by B, which is negative 3, comma, the 2 on the right-hand side where the D is. So this is now negative 1, comma, 2. Okay, that is my vertex. So negative 1, comma, 2. I have to look at my A. A is equal to negative 2, which is less than 0, so my graph opens down. Because according to what we said right here, it goes down. Then I need to find my slope. So which is negative 2 times negative 3, which is 6. So I'm going to go down 6. So from my vertex, 1, 2, 3, 4, 5, 6, I'm going to go right 1 and left 1. Okay? So there we go. Now I have my graph, and I'm going to draw my lines. There's your absolute value for this particular equation. I'm going to leave up, again, the same thing and go to the next one. The next two are absolute value inequalities, but we're doing the same process. We just have one more or two more things to kind of cover. So this inequality is right here. I'm just going to fill in the numbers for A, B, the ones that I don't actually see. That's a 1, that's a 1. Okay, I'm going to do the same thing. Find the vertex. So it's the opposite of 2 divided by 1, comma, negative 4. So that's negative 2, comma, negative 4. So that's the vertex, and let's graph it. Negative 2, negative 4. Now I need to find if A is bigger or less than 0. So in this case, A is 1, which is bigger than 0, so my graph goes up. Now my slope. Slope is A times B. 1 times 1 is 1. So I'm going to go up 1, to the right, up 1, and then to the left. Then I look at my inequality symbol. From graphing linear inequalities, it's the same step. So because it's a less than symbol, I have a dotted line. Okay, so dotted line. Again, because it's a less than, I'm shading below. Below what? Below the vertex. Whatever's below the vertex, we're shading. So if you look at the vertex, it has this whole big region. That whole big region that's below the vertex. So I can shade in everything that's in that region. All right, let's go to the last one. I have every one of these numbers filled in. That's A, B, C, D. Vertex, the opposite of 4, divide by B, comma, 5. So I get 2, comma, 5. So let's plot it. 2, 5, right up there. Is A bigger or less than 0? Well, A is negative 2, which is less than 0, so my graph goes down. And now let's find slope, which is negative 2 times negative 2, which is 4. So from this dot, I'm going to go down 4. 1, 2, 3, 4, and I go over 1, and then over 1 in the opposite direction. Because of the symbol being less than, I'm going to dot my line. If it was less than or equal to, then it would be a solid line. Again, the same way as an inequality, graphing a linear inequality. Now, because it's a less than, I'm going to shade less than my vertex. Well, where is less than my vertex? That's kind of in this little region here. It's inside that little V there. So I'm going to shade it in. And that is the answer for this particular inequality.